Hello, geometry class. I'm Mrs. Applegarth, and today we are going to do Chapter 10, Section 5, Trigonometry and Area. So we are putting together the trigonometry we learned in Chapter 8 and different shapes other than our friend the hexagon. So I'm going to take you through 4 examples, and in these 4 examples you will see all the ways that trigonometry can come into your life. So here we have a regular pentagon, and it has a side of 6. So go ahead and draw your pentagon. The side is 6, so go ahead and put that in. We're going to use a 3-step process. Step number 1 is to create your triangle. So we're going to start at the center of our shape, go from radius to the very next radius. And remember, the radius of a shape is from its center to a vertex. And then we can find this angle by taking all the degrees in a circle, so it's 360 all the way around. We know we have 5 sides. A pentagon is 5, so we divide 360 by 5, and we can see that our central angle is going to be 72. Here's the problem. We want a right angle. You can't use trigonometry unless you have a right angle. So we're going to create one for ourselves by dropping down, and in this case it's going to be the apothem. So if you drop down the apothem, it's always going to make a right angle. So then we have to go one more step because we have cut this triangle in half by creating an apothem. So we have to divide 72 by 2. So our triangle is going to be 36 degrees. It's going to take half of this side because we just cut this triangle in half. So its side is going to be 3. And the apothem is this guy right here. So now we're going to use the area. Step number 2 is find the apothem, so we can use the formula 1/2 the apothem times the perimeter. So we need to find this apothem. So we have the opposite side of the 36, and we have the adjacent side of the 36. Remembering our SOHCAHTOA, opposite and adjacent is the TOA, so we have to say tangent of 36 is equal to the opposite, which is 3, over the adjacent, which we don't know, it's the apothem. And we're going to leave it as A. That's coincidentally an A. I always, when I'm solving my trig, I put it over the magic 1, so we have a nice proportion, so we can cross multiply. 3 times 1 is 3, and A times tangent of 36, well folks, I'm sorry to say, that is just A tan 36. We are going to solve for A, so we have to divide both sides by tan 36 degrees. So in my calculator, I put 3 divided by tangent 36, and I get, just so that, let's go ahead and do that together so you can see kind of the process. Your calculator is going to be different. This one likes 3 divided by, it likes the degrees first, and then it likes the trig. Tan. And then equal sign. So my answer is 4.1. So now we know that, so we're step 2, find the apothem, so we can use the area formula. So here's my area formula here. I'm putting in my apothem, and now I need the perimeter. Perimeter is always going to be your side length, 6, times how many sides you have. And because we're pentagon, it's 5. So that is 1/2 times 4.1 times 30. Throw that in your calculator. And I always, when I'm doing it in my calculator, I put 0.5 instead of 1/2. It just is one less step that I have to do. Times 4.1 times 30. Oh, 61.5 centimeters squared. Okay, so this is what you do when you have, this is how it looks when you have your side. So just to go back, we created our triangle. We found that the angle, central angle is 72, and then we cut it in half because we need a right triangle to use trig. Then we found our apothem, and then we plugged it into the area formula. Okay, let's see what happens when we have a radius instead of our side length. So here, the steps are the same. We create our triangle. Here it is in our octagon. So this is 360 degrees. It's an octagon, so we divide by 8. So our central angle is 45 degrees. Then we cut that in half because we want a right triangle. And we see that our angle for our trig is 22.5. Because we're given the radius, that is our hypotenuse. So when we're doing our trig, we have the adjacent side, which is the apothem. So now we created our triangle. We're on step 2, which is find the apothem. So we need to still find the apothem so we can use the formula. So we go, well, we have the hypotenuse, we need the adjacent. So the trig for that is cosine. Cosine 22.5 is equal to the adjacent over the hypotenuse. Okay. So then we use our little magic 1, and we cross multiply. And we get a times 1, which is a, and 8 times the cosine of 22.5. And we do that in our calculator. Again, mine likes the angle first, so we go 8 times 22.5 cos equals, so we get 7.4. So our apothem is 7.4. Now look what happens when we try to use this area formula. 1/2 times the apothem, yay, 7.4, times the perimeter. Okay, well the perimeter is the side. Oh no, we don't have this side. Now there's 2 ways you can do side. You can use Pythagorean theorem because you've got 7.4 is your side length, 8 is your hypotenuse, and then you can find this side length here. Or I'm going to use trig because it's good for us to practice since we'll be doing trig. So I'm going to say that if our half of our side is chilling here, I know the hypotenuse, so I know that the sine of 22.5 is the opposite side over the hypotenuse. So half of my side, because it's just this little piece here, divided by 8. So I'm going to cross multiply, so 8 times the sine of 22.5 is equal to half of our side. We do that in our calculator. Don't be afraid of trigonometry because it is just it is a simple calculation. It's just a punch it in your calculator. 3.1, so half of our side is equal to 3.1. So whole of our side is double that. So our whole side is going to be 6.2. So we use trig to get half of our side, and then we times it by 2 to get the whole side. So there's 6.2, and we're looking at an octagon here, so that's times 8. All right, put it all together. 1/2 times 7.4 times 6.2 times 8, and it's just a calculator chug away. We get 183.5 inches square. So that's what you do when you get the radius. Okay. Example 3. What do we do when we get an apothem? Well, let's take a look. So step number 1, create your triangle. So we have a regular decagon. So we got this triangle here. It has an apothem of 14. So from top to perpendicular to the side is going to be 14. Let's find our central angle. 360, a decagon, it's like a decade, it's 10 sides. So 360 divided by 10 is 36. Remember, when we drop the apothem in, we divide that by 2. So our angle for our right triangle is 18 degrees. So then we look, we have the apothem, so we're like, whoo, step number 2, we don't have to do that because we've got 1/2 times the apothem. The only trickster here is the perimeter part. So we don't have this half of a side. So go ahead and draw in this little right triangle. To find the half of the side, we go, well, we have the adjacent side, which is 14, it's the apothem. And then we are solving for the opposite side so we can get our perimeter dialed in. So we go tangent, because tangent is opposite over adjacent. So tangent of 18 degrees is half of our side, it's just this little nubbin right here, divided by 14. We put in our over 1, and then we cross multiply. Half of our side times 1 is just half of our side, times tangent 18 times 14. So we throw that into our calculator. 13 times tangent of 18. And we get 4.5. So half of our side is 4.5. We are going to double it because we don't want half our side, we want the whole perimeter. So we're going to double it, and we see that our side length is 9. Here to here. So now we're back to our formula. Half of our apothem times the perimeter, which is 9, which is our side length, times 10, which is how many sides we have. We throw that into our calculator, and we get our area is 630 centimeters squared. All right, so that's when we have the apothem. One more example, this little equilateral triangle for you. Find the area of an equilateral triangle with a radius of 6 centimeters. Again, create your triangle. So when we go to create our triangle, we throw down the radius. It goes from the center here to the corner, and we know that's 6 centimeters. And watch what happens. We know this already because we're very familiar with the equilateral triangle. Watch what happens when we go, okay, find the central angle. So from here to here to here, it's 360. Divide by 3 because we have 3 sides, and we get 120. Now we divide that by 2 to find our angle here when we put our apothem in. Oh, look at this. We have a 30, 60, 90 triangle. And that's why equilateral triangles are beautiful. Okay, so let's look at our 30, 60, 90 triangle. Remember, our short side is equal to half of our hypotenuse, and our long side is equal to our short side times the square root of 3. So we can do this super quick. We got half of 6 is 3, and then we just stick a root 3 on top of that to find half of this side. All right, so if half of our side length is 3 root 3, the whole way across is going to be 6 root 3. So we go 1/2 the apothem, that's for sure, and then times the perimeter, which is 6 root 3, times the 3 sides. So we go half of 6 is 3, 3 times 3 is 9, 9 times 3 is 27. So the answer is 27 root 3, but some of you guys may want to chug that into your calculator. If you do 27 times the square root of 3 is 46.8. And that is all the scenarios you're going to find with trigonometry. One more time. All right, go ahead and take a moment, do the 10.5 practice, page 646, number 7 through 25, odd, So these numbers right here. When you're done, come back to this video and check your answers, or if you get stuck, you can come back and check your answers. Here they are. All right, and go have an amazing day.